Sir Roger Penrose, a Nobel Prize-winning physicist in 2020, once remarked on the deep mystery of consciousness, an enigma that remains largely unexplained but is essential to our understanding of reality. In a striking warning, he suggests that we may have completely misunderstood the universe. What he reveals about the true nature of cosmology is nothing short of mind-blowing. We are venturing beyond the limits of conventional science, into a realm where consciousness, its control, and its dynamics may play a central role. The James Webb Space Telescope is at the heart of this paradigm shift, delivering discoveries that challenge everything we thought we knew and potentially transforming the way we perceive existence. Its latest finding might be the most astonishing yet. Meant to uncover the earliest galaxies in the cosmos, this powerful instrument is now forcing science to confront unexpected truths that verge on being unsettling. The discovery of galaxy J0107a has sparked what many are calling a cosmological revolution. This is the oldest barred spiral galaxy ever observed, dating back 11.1 billion years, to an era when the universe was still young and turbulent. According to previous theories, spiral galaxies take several hundred million years to form, and bar structures appear only after billions of years of galactic evolution. Back then, galaxies were expected to be small, chaotic, and dominated by violent star formation. Yet J0107a defies those expectations. It exhibits an astonishingly well-organized spiral structure, complete with a distinct central bar. Its very existence contradicts long-standing models and poses a fundamental question about the nature and timeline of galaxy formation. Have we been wrong about how the universe evolves? Thanks to the James Webb Space Telescope and the Atacama Large Millimeter/Submillimeter Array, ALMA, scientists have discovered a galaxy known as J0107a. What makes it remarkable isn't just its unusual structure, but its star formation rate, which far surpasses that of our own Milky Way today. This challenges what we thought we knew. The findings suggest that our current model of cosmic evolution may have serious flaws. The discovery of J0107a is pushing astronomers to revisit long-held assumptions about how galaxies form and evolve. Could there be unknown physical processes at work? Or is it time to rethink our entire understanding of the universe's origins? The question of cosmic evolution is more open and thrilling than it has been in a century. Think back to when astronomers first realized that the dark nebulae in the sky were actually other galaxies. That breakthrough reshaped our understanding of the cosmos. Now, we may be standing at the edge of another scientific revolution. We've estimated the age of the universe and traced the formation of matter from its very beginning to the emergence of the first stars. For a long time, our understanding relied on mathematical models, until the James Webb Space Telescope was developed to provide real observational evidence. But instead of confirming our theories, it's challenging them. Now, we may need to rethink everything. One key example is galaxy J07a. It's just one of many recent discoveries suggesting that something in our current model doesn't add up. Astronomy now faces a major puzzle. How could a well-structured barred spiral galaxy like J07a exist 11.1 billion years ago, when such formations weren't expected until much later? According to the standard model of cosmology, galaxies form gradually over time. Smaller galaxies collide, merge, and slowly evolve into larger, more organized systems. Spiral galaxies, like our Milky Way, were thought to represent the final, mature phase of galactic evolution, forming only after billions of years of chaotic growth and interaction. But the existence of J07a tells a different story. It suggests that spiral structures could form far earlier than we thought, shaking the foundations of our understanding of galaxy formation. Current models are built on the idea of slow, turbulent evolution, chaotic collisions, fragmented structures, and prolonged star formation gradually giving rise to stability. J07A, however, shows a level of order and development that defies those expectations. This raises the possibility that we're underestimating how quickly stars and spiral structures can emerge. Perhaps our models are too simplistic, too linear and mechanical. It may be time to explore new physics. One emerging hypothesis is that cosmic magnetic fields and gravitational resonances played a much more significant role in the early universe than we've assumed. Some regions of space may have evolved under entirely different conditions, enabling galaxies to grow more rapidly and with greater organization than we ever imagined. Alternatively, the process of cosmic reionization, the era when the universe transitioned from the dark ages to becoming transparent, might have unfolded in a way we didn't expect, enabling galaxies to form and evolve much more rapidly than previously thought. The discovery of galaxy J0107A adds yet another provocative question to the mix: could our understanding of cosmic expansion be fundamentally flawed? For decades, the redshift observed in distant galaxies has been taken as strong evidence that the universe is expanding. But what if this widely accepted interpretation doesn't tell the full story? Unusual measurement data and mysterious galaxies like J0107A may point to an overlooked physical mechanism, something we've yet to understand. Enter Nobel Prize-winning physicist Sir Roger Penrose, whose groundbreaking theories suggest a deeper connection between the structure of the universe and consciousness itself. His research bridges physics, quantum field theory, and the science of consciousness, uniting fields that often stand at odds. Penrose proposes a radical idea: what if the universe's expansion isn't a literal stretching of space, but rather a shift in fundamental physical constants, one linked to changes in cosmic consciousness? It may sound outlandish, but in quantum physics, we already know the observer influences experimental outcomes. In this framework, the observer, consciousness, might be playing a much larger cosmic role than we ever imagined. Could we be making a fundamental mistake by assuming that physical quantities and forces alone shape, sustain, and explain the cosmos? What if the universe is actually influenced by consciousness, one that, like us, makes decisions and could even choose to alter the flow of time itself? In that case, our scientists, armed only with compasses and rulers, might be chasing after something far more dynamic and profound than a simple mechanical universe. Imagine a cosmos that thinks, one that renews itself in cycles, just like nature continually regenerates life on Earth. It sounds wild, but it's a possibility worth considering. This idea echoes the hypothesis of Sir Roger Penrose and other thinkers, who suggest that the universe's apparent expansion might just be an illusion, an effect of shifting properties in spacetime. Some researchers argue that we perceive the cosmos through a distorted lens, limited by the constraints of our own consciousness. Perhaps spacetime isn't the stable, unchanging fabric we've always believed it to be. Maybe our tools for measuring it are inadequate, trying to confine something vast, fluid, and unimaginably complex within human-made limits. Sir Roger Penrose, awarded the 2020 Nobel Prize in Physics for his groundbreaking work on the mathematics of black holes, demonstrated that their existence naturally follows from general relativity. But Penrose's ideas stretch far beyond black holes. They challenge our very understanding of reality and invite us to reconsider the nature of the universe itself. Black holes may hold a key role in shaping a new understanding of the universe's structure. Physicist Roger Penrose introduced the idea of cyclic cosmology, which challenges the notion that the universe began with a single Big Bang and has been expanding endlessly ever since. Instead, he proposed that the universe goes through repeated cycles of expansion and contraction. This theory could offer insight into mysterious objects like galaxy J0107A, which seem too ancient to exist in our current cosmological timeline. If the universe truly operates in cycles, some of the oldest galaxies might be remnants from a previous cosmic era. Alternatively, the universe may not reset from a single origin point but instead go through regional, seasons, or cosmic climate zones, patterns and processes as unpredictable as the complex dynamics found on Earth.